All right, so before I do anything, I'm going to go ahead and make sure I'm in degree mode, right? So I'm going to go check my calculator mode. I'm good. All right, so quit. Number 4, well, I just have to solve for x. So we're going to go, minus 5, minus 5. So I got 4 secant theta equals negative 5. Divide by 4, divide by 4. Secant theta is negative 5/4. Secant is not in your calculator or in the circle, but cosine is, right? Cosine is. So we're going to change it to 1 over cosine is equal to negative 5 over 4. And that's the same thing as cosine of theta equals 4 over negative 5. Okay? So I need to find the angle. What button do I push? Right, so I'm going to go cosine inverse of my 4 over negative 5. I'll just, I need the room, so I guess I won't do E. So I'll go cosine inverse of 4 divided by 5. About 36.9 degrees. I'll round it up. So theta 1 is 36.9 degrees. Okay, now cosine.
Oh, wait, I have a question.
Yes.
So sometimes like the first angle like answer you get isn't actually the right answer, and you have to like subtract some fragment to it. How do you know if it's the right angle?
When it becomes negative.
Okay.
In fact, anytime we're going to learn this eventually, but anytime you get sine inverse of a negative number, you get a negative angle. Tangent inverse of a negative number, you get a negative angle, not cosine. And we're going to actually draw the graphs on Monday, and you're going to see why that happens. So on Monday, when we draw the graphs, you'll say, oh, I see why that works. Okay? For right now, it's just kind of doing a circle thing, right? Negative values. And closest to 0. Also comes back to the closest to 0. Okay. Okay. So 36.9 degrees is. I'm going to put that in there. Okay. So here's my 36.9 degrees. And that is really a cosine value, right? Oh, I made a mistake. Nobody caught that. I did make a mistake. Cosine inverse of a negative 4 divided by negative 5. I did make a mistake. I forgot the negative. I knew that was wrong. 143.1. Okay, and I'll draw it up here, okay? 143.1 degree, okay? Lousy picture, but we got the idea. So let's see what I got. This makes sense to me because negative 4/5, like negative 0.8, right? So negative 0.8 is about here, so my angle's got to be right about there, right? So I draw in that x part, so I've got an angle there, and I can have another angle here. Does that make sense? I'd have to have another angle here. So to get this other angle here, let's see if we can make sense of this. I want to flip it over here, right? That's the angle I want. This angle here would be 143.1 also, right?
Minus 360.
Yeah, you see the minus 360, don't you? You totally see, because if this is here, and you need this angle here, you've got to subtract from 360. Yeah, you see, don't you, Kai? Good. So we're just going to take 360 minus our angle. And so I go 360 degrees minus my 143.1 degrees. 216.9, right? And does that look like that angle's in the right place for 216? It does to me. I mean, yeah, I know that's 180 and that's 270, so it sure seems like it's in the right spot, doesn't it? Okay. So Lauren asked some questions. Well, Lauren asked a good question, okay, and I'm gonna give you a little hint. When it's cosine, with cosine, to find theta 2, the second angle, with cosine, it's always going to be 360 minus the angle. Find the reference, call it the reference angle of the second angle. Okay, that's always going to work. Okay, always. Sine and tangent are a little bit different. Okay, so we'll keep going. Okay, now let's shift it down and take a look at the next part. So I know there's a couple of them I want to do in the next part. Okay, let's do B. Let's do B. Okay. I don't need to do them all because it really gives you guys time to work on your class, right? Now look at B. First thing I notice is the mode. Do you guys see that? First thing I notice is the mode. So I'm going to change my mode. Now we're 0 to 2 pi, right? So I'm going to my calculator, clear it. I'm going to go mode, radians, boom, okay? So on B, I'm going to get rid of A. I'm just going to solve. So minus 1, I'll get 3 cotangent of x over 5 equals negative 1. Multiply by 5. 3 cotangent of x equals negative 5.
Wait, why did you change this one?
Say that again.
Wait, why did we cross over 4? Sine of x?
I just don't have room for it. I can do it. I can do that. I'm just,
Oh, we're not doing that one. Oh, sorry, I just did that.
yeah. Yeah. Next time I do this worksheet, I'm going to give less problems and more room. Ellie, how's that sound for a good idea, huh? Okay, divide by 3, cotangent of x equals negative 5/3. Cotangent is not in your calculator, not on your circle, but you can change it to 1 over tangent of x equals negative 5/3. Or tangent of x is equal to 3 over negative 5, because I just flipped the fraction, right? We talked about that yesterday, how it flips it. Okay, now, I've got to find the angle. X is an angle. And this book that we're using makes it a little bit easier for us. It helps, okay? You ready? Listen. The book uses x for radians, and it likes theta for degrees. Have you noticed that yet? Well, I'll just tell you. They like x for radians, and then like theta for degrees, okay? So that sometimes will help you. You see the x, you're like, oh, I think it's in radians, right? So let's do tan inverse of 3 over negative 5. Now the angle's not going to look like an angle because it's in radians, but that's okay. So I'm going to go tan inverse of 3 divided by negative 5. And I get a weird answer. I get a x1 equals a negative 0.54, okay? Yes.
Can you teach the negative to the negatives as well?
And convert when you're done? Yeah.
Oh, okay.
Yeah. Keep that secret to yourself, please. Okay, I'll tell you. Here's what Ellie's saying. Just keep everything. Ellie's saying just keep it all in degrees because it's easier to understand degrees, right? Get your answer at the very end, like our last answer, and just convert our answer to radians using the conversion to should. That's actually really good.
But then when we had degrees, when we had the negative degree, I had to like add 360 to it or whatever.
Right.
Why don't we do that?
We're going to.
Oh.
You're ahead of me, as always. I like that. So we can't have a negative, can we? So we're sitting down here. We're sitting down right about here. This angle is about a negative 0.54 radians, right? It's right about there. Remember that 57 degrees is 1. Does that help? 57 degrees is about 1. If you keep that in mind, 57 degrees, 1 helps. So this angle here, and this angle is 3.14. Okay? So Ellie, you're right. We're going to add 360, but not really.
We're going to have 2 pi.
Yes. Everybody right there?
Yes.
You're going to add 2 pi. So let's add 2 pi. spins it all the way around, okay? Okay, just gonna do that. Yep.
That makes more sense.
Yeah, it makes sense, doesn't it? So I'm gonna add 2 pi. So really, x1 is gonna equal negative 0.54 plus 2 pi, which spins it all the way around, so plus 2 pi, about a 5.74. Yeah. So x1, angle 1 is about a 5.74 radian. Okay, so all right. So this angle here is really a positive 5.74. 6.28. I'm going to say it again. 6.28. 3.14. 3.14. 6.28. So 5.74 makes sense. It does. Okay, and it's in the right spot. Now we know the other one is going to be its tangent, right? So tangent was a spin of 180, right? But not 180, but what are we going to subtract? Pi. Yeah, so we're going to take this answer, we're going to subtract pi. Get that, I guess I'm going to go minus pi here. Okay, let me do it on the worksheet. So we're going to go x2 is going to be my 5.74 minus pi. And I'm going to get a, let's see, 5.74 minus pi, and I can answer about 2.6. About 2.6. We don't have to be perfect on a rounding. We just need to get to the angles, okay? Okay, now, so I think what we need to do today is, and I got one more thing I want to show you, okay? One more thing, because you're going to need to see how to do number 24, okay? So, I don't know if you guys have a separate sheet of paper or in your notebook, but I want to pose a question for you, and then I'll be done, okay? So, let me write this out, and then we'll do it together. So, a line has an angle of inclination of 60 degrees and passes through the point negative 3, 4. Okay? Find the equation of the line. Okay, go ahead and write that down, and we're going to solve this one, okay?
I think I can do that one.
Huh?
I think I can do that one.
Of course you can. Well, give me a thumbs up when you got it written down. Got it? Okay, I'll wait for everybody. I want everybody to write this down. So for me, a picture, if I can draw a picture, sure helps, right? I know I just saw Brittany grab graph paper. I don't know if I need graph paper, but she's got the right idea, so I'm going to grab some graph paper. You don't need graph paper, but you know, why not get a good picture of this, okay? Right. My ruler is broken right there, huh? Okay. Broken protractor too. Everything's broken these days, huh? Wow. Broken ruler, broken protractor. Anyway. There you go. Okay, there's a picture of it. Okay. So find the equation of a line. So it passes through negative 3, 4, and I've got a 60 degree angle, okay? What do I know? What do I know?
60 degree angle and it passes through negative 3.
Great, okay, awesome. So let me draw in the 60 degree angle here. You okay with that? How do we find the equation of a line? Y equals mx plus b, right?
I read that
I know, right? And M stands for what? Slope. So M is the slope. But the slope is 60 degrees. That's just not going to cut it for me, okay? Slope is 60 degrees, right? Well, slope is rise over run, correct? Slope is rise over run. Which is opposite over adjacent, opposite over adjacent, opposite over
Should that be the
adjacent.
tangent?
Let's use tangent. If I take tangent as 60, it's like the ratio of opposite over adjacent. Does tangent make sense?
Yeah, okay.
Tangent makes sense because tangent's going to be the opposite adjacent. So if I take tangent of 60, I'll have the opposite over adjacent. I really will, because all tangent is a ratio. So let's take tangent is 60. What mode should it probably be in?
Degrees.
Degrees, right? So if I take, so here's something to write down. Slope is always going to be tangent of theta, always. So slope is always tangent of theta. I'm going to go into degrees. All right, so I'm going to go, okay. Check my mode, degree. I'm going to go tangent of 60.
What is it, what do you want?
And I get about a 1.73, okay? That's my slope. All right, so now let's do our y equals mx plus b. Y equals 1.73x plus b. All right? Now we got to find b, but you know how to do this. You do. We got to find b. What can you do to find b?
Plug 0 into y.
We're
And
gonna
x,
plug,
x, x,
4 into y and negative 3 in for x, right? 'Cause that's my point, right? Because it's got to go through that. Let's write that down.
Yeah, the y-intercept,
I don't know what the y-intercept is.
but can you plug in 0 for x and then find the y-intercept? Oh, because.
You don't know the y value. Right? If you plug in 0 for x, you still have two variables, don't you? Because we don't know the y. You can guess. You can guess when you get your job doing it. But let's do it this way. Lauren, you're not wrong, but it's more difficult to do it your way. Okay, by the way, you're not wrong. I'm going to do it this way. I've got a point at negative 3, 4. I'm going to go 4 equals 1.73 times negative 3 plus b. Okay. 4 equals, I don't know, negative something or other, right? I don't know, times that by negative 3. And I get a negative, just negative 5.2. And then if I add the 5.2, b is a 9.2. And then finally, my equation is y equals a 1.73x plus a 9.2. You have the right idea, Lauren. But I think it would have been hard to do it that way, okay? Okay, so here's what I want you to do today, okay? I want you to do the 14 to 24 even on page 299, okay? Some of these are going to be in radians. These last few are going to be what we just did, all right? And then I'm happy to help, okay? We have lots and lots and lots.